Welcome to lesson 3.3, where we are going to talk about the fundamental theorem of algebra. Now, the fundamental theorem of algebra is actually, it sounds very intimidating, actually pretty simple. All the fundamental theorem of algebra says is that the biggest degree or exponent of your polynomial equals the number of roots / zeros / solutions. So something to know about this, these three words right here, if you see all of these, they actually mean the same thing. Roots, zeros, solutions, all synonymous. So what they're meaning is if I take, let's say, this equation in example number 1. I set it equal to 0. If you solve that, you're going to get x equals something, meaning a solution to that equation. This is a solution of that equation. These x equals something are also the roots of that equation. They are also the zeros of that equation. All three of those words mean the same thing. It means solve it out, get your answers. And what the fundamental theorem of algebra says is your biggest exponent, so in this first one, x to the fourth, your biggest degree is how many solutions your equation is going to have. So this equation right here should have 4 solutions, 4 roots, or 4 zeros. So let's go through and try to solve this and make sure it has that many things. So if I'm going to solve this equation, the first thing I'm going to do is check for a GCF. Well, I see they both have an x squared in common, so I'm going to take that out. Now I'm going to check to see if I can factor anything else as much as I can. Well, I can't factor that, so that's done. I can check to see if I can factor that. So I have x squared plus 49, or x squared plus 0x plus 49. So going back to our factoring from last chapter, that means I'm going to need 2 numbers that will multiply to 49 and add to 0. So some of you might think, well, 7 and 7. That multiplies to 49, but that doesn't add to 0. Well, -7 and +7, that adds to 0, but that doesn't multiply to a +49. So this one actually is very special in that it cannot be factored. If it can't be factored, we've got to do the quadratic formula. So let's start with this. I know that x squared is a solution, so I'm going to set that one equal to 0. And I'm going to set x squared plus 49 equal to 0. I can't factor that. I could do the quadratic formula on it, but I actually have a shortcut for you. If your equation does not have a middle term, so no x term, you don't need to factor or do quadratic formula. You can just straight up solve it. But that only works if there's no middle term. So here's what I mean by solve it. Let's minus 49. So I have x squared equals -49. And then I can square root. So you can see because I didn't have that middle term, I can just subtract and square root to get my answer. Now, something to remember, anytime you square root, you get a plus or minus. And if you simplify this out, you're going to get an imaginary number. I'm going to split this up like this. We know those are the same. And then I have plus or minus square root of 49 is 7. Square root of negative 1 is I. So right there, I've got two solutions, or roots, or zeros. I've got a positive 7i and a negative 7i. But we said it's supposed to have 4. Right now, I only have 2. Well, the other 2 come from this, because if this is x squared equals 0, it's actually 2 x equals 0. So those are my other 2 solutions. So you'll notice we said this should have 4 solutions. Well, I have 1, 2, 3, 4. That's what the fundamental theorem of algebra says. Your biggest degree polynomial is how many solutions you should have. So if I look at example number 2, I'm not going to make you solve this one. I just want you to show how many solutions it should have. Well, I look at the biggest degree is 2. So that means this should have 2 roots, or zeros, or solutions. You can use any of those words. Should have 2 of them. Now, if you look at your assignment is 3, 4, 5, and 6. But I'm going to simplify this. I don't want you to solve it. I just want you to state the number of roots. So, quick and easy, just finding the biggest degree and saying this should have 2 roots. This should have 4 roots. That's all you need to do for 3, 4, 5, and 6. In the next video, we'll do this next example and talk about a slightly different application of the fundamental theorem of algebra.